Welcome to the afternoon track. Our next presentation from Gergely Nagy, syslog ng, Riemann and Kibana, and how to monitor with these tools.
Thank you. Now it's working. First of all, my talk will be about monitoring with syslog ng, Riemann and Kibana, as announced. I'm Gergely Nagy, usually known as Algernon, which can be pronounced by people not from Hungary. So if you want to talk to me after the talk, you can find me. Don't try to pronounce my name, it will not work. It never does. I work for a company called Bonabit. We are the main developers behind syslog ng. I'm working on the open source version of it, and I'm proud to say I have not touched the commercial version in 3 years. So let's begin. First, a few words about the tools I will be presenting. Syslog ng is an open source event processor, and as we like to call it, a Swiss Army knife of logging. Whatever you want to do with your logs, you can do it with syslog ng. It's been in development since the late 90s. It has always been open source. It used to have a contributor agreement in the beginning, but we don't have that since about 5 years, thankfully. If you're into that kind of thing, we have a commercial offering since 2007. It is available for all kinds of nasty platforms like AIX, HPUX, Solaris, all kinds of weird things, but the open source version works there too. Syslog ng can collect logs from all kinds of sources, files, networks, I don't know, databases. It can parse them according to various rules. It can, of course, do syslog, even Cisco logs, and various other things people like to call syslog, which are not. It can parse JSON, so if you have a quite modern system or an in-house developed application, you can send it to syslog ng. It will collect them, parse them, filter them, transform them, whatever way you want before you send it further to another application. It also has a lot of so-called destinations. We can send logs over to other syslog servers. We can place them into files, put them into databases, SQL databases, MongoDB, Redis. We can forward them to Elasticsearch, Riemann, and a lot of other things. Oh yeah, and it also has a wide variety of plugins, both built into syslog ng and a few plugins which are distributed separately. I will have a couple of URLs at the end of my presentation, which will be available after the talk as well. So if you're interested, you can check them later too. We also have a very sizable, helpful and very inclusive community, both on Twitter, on mailing lists and forums as well, and IRC too, reasonably recently. The other tool I will talk about is Riemann. Riemann is, well, a system that monitors distributed systems. It's pretty much an event aggregator with a very powerful stream processing language. What it does is you send it protocol buffers events, or well, events formatted into protocol buffers serialization format. It can aggregate them. It can filter them and do various stuff with them, which I will explain later. So it's much, much more than a collector, and you have a whole language with which you can do very interesting stuff with your data. This language, by the way, is called Clojure, which is a Lisp language built on the Java virtual machine. It provides a low latency transient shared state. So it pretty much means you have an index which you can query from outside, which holds the actual state of the data you sent in and which you aggregated. There's the third application I will talk about, which is Kibana. You will likely hear more about it during the day and the next day. And there are people much more knowledgeable about it than me on this conference. I will only touch the surface of Kibana, by the way. Kibana is a tool with which you can visualize your logs and pretty much any kind of timestamp data. It is a very powerful search syntax. It builds on Elasticsearch. It has a flexible, powerful, and intuitive user interface. I'm not sure how well you can see this screenshot, but this is pretty much how it looks after a few moments of configuration. So, what you can do with these tools and how to plug them together. To know that, first we need to know what we want to monitor, or what we can monitor. We can, of course, monitor system state, such as hard disk space, network bandwidth, CPU usage, memory usage, the state of the RAID array, the number of virtual machines running, that kind of stuff. We can monitor application state, either from within the application or with an external program such as Gergely or Nagios. You can check whether your web server is running, whether your SMTP server is correctly sending out mail, or if your home-built application is serving your data at a reasonable speed. You can also monitor exceptions, which is fairly common when you're doing agile development. You just deploy something new and see if anything breaks. Plenty of people seem to like doing this kind of thing. You can monitor activity. For example, if you have a website, you can monitor which links people clicked on. Think Google Analytics, which is kind of a monitoring tool as well, except it's from the other side. Then we have the usual tools, Nagios, Gergely, Munin, and of course we have Riemann. So we have the usual tools. I'm not going to explain all of them. I'm pretty sure most of us have a rough idea what we want to monitor. And most systems already have some kind of monitoring in place. So what I'm going to offer instead of giving you hints what to monitor is how to bind it together with logging and what that will buy you. Well, this is a kind of logging too, but this is not what I will be talking about. Logging is it has very So it has a lot of things in common with monitoring. Except with monitoring, you pretty much pull the information out of the application or teach the application to send you events. With logging, if done right, and very few people and very few projects seem to get it right, what you do is persist application state. You pretty much make an event that at this time of the day, this was the application state, this happened. It should be kind of like a diary. Unfortunately, the format is usually application specific. Most of the logs out in the wild are unstructured. They have some kind of little structure, like either the old BSD syslog format or the slightly improved syslog format, which has time zones and beginnings of structured data. Or they have an application-specific format like HTTP daemons logs, which usually follow whatever example Apache set. Then we have the MySQL logs or SMTP server logs. Pretty much every one of them is different. And you need a tool to make sense out of that. That tool can be syslog, Logstash. There are plenty of them. What I prefer to use is syslog, obviously. Primarily because that's the lightest of them all, which can do what I want. But what you need to know about logging is that it's not just for debugging. It's not just there to help you figure out what went wrong or what happened. It's a very good source for monitoring too, because there are a lot of legacy applications which you can't really talk to from the outside. They don't have any interfaces to tell you what happens inside them. The best you can do is look at the log files or events they spit out and try to make some sense out of that. And that is where monitoring and logging comes very nicely together. So, what do we already have? If you have a monitoring system set up, you will always be aware how your systems are behaving. You will know when some extraordinary thing happens. If you run out of disk space, you will know. You can draw pretty graphs out of it. You can do reports, alerts, you name it. We have that already. If you have Google Analytics or a similar analytics solution, you know how many visitors you have on your website. You know what they clicked on. You know what browsers they use, what kind of equipment they use. You can be pretty sure whether they have JavaScript turned on or off, because if they have it turned off, you will obviously have much less information. What can we add to this mix? What do we have in the logs which are otherwise not available for most monitoring tools? Well, we have quite a lot of things. For example, we have the HTTP servers logs. Why is that useful if we already have Google Analytics? Well, first of all, when you meet with a security and privacy conscious user, he will likely have JavaScript turned off, or at best, most analytics services, such as Google Analytics, turned off or blocked. But if you have your HTTP logs, you will know what sites he checked, what pages he looked at, where he came from, although that information is a bit flaky. So if you take that out from the log files and pipe it back to your monitoring system, you will have much more information. Information you wouldn't have access to if you didn't have your logs. Or, to take another example, you have an SMTP server. You can easily monitor the traffic on the usual ports, but if you don't have the logs available, the information you have is very limited. Most servers can be reached through SNMP or a similar solution, but as far as I found, the logs have much more information. They have much more information about what went wrong, what the other side said about a rejected mail, how many times it has retried resending a mail, and a lot of other things. If you have an SQL server, those are much better when it comes to monitoring, but there are still a lot of things in the logs which are very hard to reach otherwise. For example, if you want to, during development, see which requests or which commands took the longest time or were executed the most times, one of the easiest ways to reach that information is having a look at the logs. Most programs, most daemons can be configured on the fly to enable and disable logging, or, well, debug logging, or tracing if you prefer. So when you deploy a new feature or a new software, you can just enable debug logging for a very short time, and then extract useful metrics out of the logs. Which useful metrics we'll talk about a little bit later. I already touched this part, how we will benefit from all of this. And this is where the interesting part of the talk comes. Unfortunately, I have problems reaching my server, so even though I wanted to do a demo and show it to you on the screen how it all looks, since my server seems to be offline, we'll have to use our imagination when I describe what kind of things you can put together. So let's go back a few steps. We have a brand new shiny web page. Just launched, marketing did a very expensive campaign to get the word out, and now you want to see how the website fares. On one hand, you have Google Analytics. On the other hand, you have all the little building blocks behind this whole thing. You can take the normal logs from your system, syslog mostly. You can look at all the little programs your system admins forgot to disable when setting up the virtual host quickly. Apart from analytics, you can mix it up with the HTTP logs, as I mentioned before. syslog has quite a few tools to help you with that. We have a feature called PatternDB, which is very similar to Logstash's grok. It pretty much means you can write your own parsers and extract data out of log lines, which are pretty much unstructured. We also have a reasonably large collection of such patterns. We have patterns for postfix, Apache, I believe for MySQL as well, and plenty of other daemons. With this, you can extract, for example, from an HTTP log, the visitors, the referrers, and with the help of our syslog-ng's Riemann destination, you can forward it to Riemann, and with Riemann, you can do aggregation on the data. For example, you can tell Riemann that you want to see the last, let's say, 15 minutes of the website traffic, all the IP addresses that visited the site. You want another metric based on this. For example, you want to know that at any moment in time, how many of your visitors okay, sorry, I'll start the sentence again. Let's say the site has been running for a few days, and you want to compare how many visitors you have today compared to the same time yesterday, or how many visitors you have today, how many percent more do you need to reach yesterday's performance. With Riemann, you can do that. You just group together a number of metrics and do all kinds of calculations on them. And when you have all of your logs available, the limits are pretty much endless. You are not limited only to IP addresses. You can extract the pages people looked at. You can put that side by side using the graphical interface of Kibana. Let me just go back there. There. So, one of the great things about Kibana is that it can draw pretty graphs, and you can build your queries and your graphs using a web interface. Now, if you pump all your logs into Kibana, and you also pump all your monitoring activity into Kibana, you can set up metrics side by side, and then it becomes obvious when something is not right, or if something is very, very right when it comes to traffic, for example. You can monitor the number of logged in users, show a graph from that, and put it on top of another metric, like number of visitors, and then you have pretty much, then you know how many of your visitors are actually logged in, which can be a very useful metric to have too. Or if you have a web-based shop, you can draw a graph about sales and combine it with another which displays the active how do you say it in English? When you sell a few things cheaper for a limited time, discount, yeah, thank you very much. So if you have running discounts and you have the number of logged in users, and you also know how many items you are selling from any number of items, you can put that together, display it, and I'm pretty sure the marketing guys or the sales guys would be very happy to see such detailed information, because I'm pretty sure it would make their job a lot easier. By the way, if you have questions, just raise your hand and yeah.
By saying it, you pushed it into Kibana, you mean that you use Elasticsearch as a backend, or?
Yes.
So you put everything in Elasticsearch, you log?
Yes. Let me just repeat the question for the recording. The question was whether everything is put in Elasticsearch. Yes, everything is put in Elasticsearch. Well, most everything. Riemann has a running index that is contained within Riemann, but everything that goes into the Riemann index also goes into Elasticsearch, and that representation is what Kibana can query.
And also performance metrics as well?
Performance metrics as well, everything. Everything I want to see, I send it to Elasticsearch in the end. I have syslog ng on one end to collect the logs. I have various collecting tools on the same side, collect the Nagias, whatever, which collect monitoring events from various sources. And all of these are sent to Riemann, which does the aggregation, calculates metrics for me, and sends it forward to Kibana. Syslog ng can also send it forward to Elasticsearch. So you have access not only to the metrics and the process data, but you also have access to the row logs. And that makes it possible to correlate the two and set up relations between them.
The normalization is done in syslog ng?
Partly. Normalization is partly done in syslog ng. When you're reading from unstructured logs, you can send the whole thing as it is to Elasticsearch, which is useful in its own right. But if you can extract further information to make sense out of the log, to extract IP addresses, or let's take, for example, an SSH login. You can extract where it came from, which user logged in, when he logged in, what method was used for logging in, public key, passwords, that kind of stuff, which makes the logs even more useful, because then you can draw a graph about public key logins versus password logins, which makes it very easy to migrate from one to the other and see how your users are dealing with the migration, for example. Riemann does another round of normalization. Syslog can do a lot of things, but it's not really good at aggregating and transforming bulks of data. It's pretty good at doing that on single log lines or a couple of log lines, but when you have a large body of data, syslog isn't terribly good at doing transformations on that. On the other hand, Riemann, which has a very powerful language behind it, and tons and tons of libraries to help you calculate whatever metrics you need, it can do a lot more. With Riemann, you can do grouping. You can kind of do that with syslog as well, but not quite as powerful. With Riemann, you can do fixed time grouping, meaning it takes snapshots at every 5 seconds and does some calculation on that. You can do moving time grouping, which means it takes the last n seconds, or you can do any of these based on the number of events or the last few events. This is something syslog can't really do, and it wasn't designed to do that. With Riemann, on the other hand, this is where it excels at. Grouping and so it can group stuff together. It can also take things apart based on properties discovered earlier. You can split a stream into substreams and do different calculations on them. For example, if you have, let's say, a stream of login events coming in, you can split it into 2 streams, one for privileged user logins and one for normal user logins. For primitive user logins, you can do a metric on how long they stayed logged in, because when a privileged user stays logged in for a long time, that's probably not what you want to see. On the other hand, when an unprivileged user logs in, you can do a completely different metric. For example, how many links this unprivileged user clicked on the interface. Not really sure why that would be useful, but perhaps you are testing a new user interface, so that's an option as well. So these are the main things Riemann can do for you. And as you can see on the picture, Kibana can display them in a very, very friendly way. And yes, what else did I have? Oh, yeah, exceptions. So, exceptions are an interesting thing. There are many services built around handling exceptions and displaying useful data out of them. And with syslog and Riemann, you can pretty much do whatever you want with them. You can split them by program. Well, when you have an exception, how do you handle it? First, you handle it within the program and either crash or try to recover. But most of the time, if you want to be nice to your system administrators, you also store or send those exceptions somewhere for debugging purposes and for debugging purposes mostly. Now, if you send those exceptions to an outside service, for example, PagerDuty or Sentry or any of the many others, they allow you to display the exceptions, do some simple metrics on them, but you don't really have that much control. With the combination of syslog and Riemann, you have a lot more control, although it's much less friendly to configure this, because both syslog and Riemann has to be configured with a text editor, most of the time anyway. But on the flip side, you have more control. And if more control is what you want, this is what you want. For example, so exceptions. You can pick the exceptions apart line by line. For example, if you have a Java exception, that will be quite a lot of lines. You can do a metric on how long an exception has been, which is a pretty useful metric you can show to your developers, saying that if you have a stack trace of a couple of 100,000 lines, that probably means that your program is overly complicated. That's a metric you normally don't need to use, but I've seen such things and it's terrible. You can also follow the development of an application based on exceptions. You can check what kind of exceptions occur. I/O exceptions, couple of application-specific exceptions, and it's very interesting to see how over the development of a product these exceptions start to vary. In the beginning, you'll have lots of I/O exceptions because who cares about guarding the I/O layer? It will just work and the kernel will take care of it. But once those issues are fixed, you'll have other exceptions. As people start to discover how to use your APIs, they will undoubtedly discover bugs as well. And having a graph of what kind of exceptions occur is very useful for developers, probably more useful to them than to system administrators. And with Riemann, it's very easy to classify them. And with a syslog before Riemann, it's very easy to collect those exceptions because they have a reasonably standard. Well, the exceptions itself don't have a reasonably standard format, but with syslog you can hammer them into a format which is useful for Riemann and which is useful for any other tool you may have on your chain. Okay, yes?
If I say Riemann is a correlation engine, that is
that's part of it, yes.
also a transport layer or not so?
Not so much. Riemann can pretty much, well, to send events to Riemann, you need to use its own protocol. It uses protocol buffers serialization format, and it has a few fields within the format, like the name of the event, the host it came from, the state, a description, and oh, I forgot to mention it, but this is important. Events in Riemann have a field called time to live. So events can expire, and you can set Riemann up so it notices when an event expires and it generates an event when that happens. So, for example, you're monitoring a program which should be running all the time. And if it doesn't send an event for, let's say, 5 minutes, then the last event from it will expire, and when it expires, that can raise another event, and you can send an alert based on that information. Or you can do a metric, availability metric, based on how often events expire. Let's say we have a cluster of app servers, and you are testing a new load balancer. So you are looking at the HTTP server logs and collecting how many requests it serves. And you want to know whether the load balancer works, and you want to compare the load on each server within the cluster. Before this load balancer was set up, you knew what the daily traffic of your site is, or hourly traffic, or something like that. So you divide that number by the number of servers you have, and maybe with a little bit more to give it a little moving space. And if you expect there will be 100 requests a second, and you have 2 servers, then you set the time to live time accordingly. So if the load balancer doesn't work and only sends requests to one of the servers, or mostly to one of the servers, then the other will expire, and you can draw a graph from that and see how well the load balancer works over time. You can turn knobs on the configuration and see how that affects the performance. You can also do that with any kind of other application where you can collect performance metrics. Turn a few knobs, send all the metrics into Riemann, aggregate and compute the performance over a period of time, and display it with Kibana, laid over each other. You can do a graph where it shows last week's performance on the bottom, and overlay it with the current week's performance, for example. That's a very useful metric to have as well if you're deploying new features frequently. Okay, I believe I said everything I wanted to. Unfortunately, I can't present the demo because my server still appears to be offline. If you have any other questions, I'm very happy to answer. Otherwise, I'll go to the end of my slides and show you where you can get more information. Yes?
Is there any component in this construct is able to queue something like
Well, syslog has a built-in queue. So if you have more events coming in than you can process, then it can queue it up in memory only at this time. So if you have bursts, it will survive that without losing logs. I'm not sure if Riemann has a queue, but I'm pretty sure it does. syslog can also send log events to AMQP. It's not able to subscribe to AMQP as well, but we're working on that too. So in the near future, you will be able to put a dedicated queue between syslog and then you can have syslog on the server side, an AMQP broker somewhere else, syslog client reading from the AMQP servers and locally forwarding it to your Riemann cluster. Any other questions? Well, if there are no other questions, then I'll show you this one more slide with a couple of URLs. The first one is the website of syslog with a lot of other pointers to IRC, Twitter, documentation, that kind of stuff. The second one is the syslog incubator, which is a collection of experimental module plugins. For example, the Riemann plugin is in the incubator. The Elasticsearch plugin is in the incubator. We also have a graphite output in that collection. We are working on an HTTP source and HTTP destination, which will likely go to the incubator as well. The incubator also has Lua support, which means you can write sources, parsers, and destinations for syslog without ever having to touch C code purely in Lua. We are also working on a Python plugin, so soon you will be able to write syslog plugins in Python as well. The last two URLs are blogs. The bottom one is my company blog, lots of information about syslog new features and what we're working on. And the top one is the blog of one of my colleagues who did a lot of work on the incubator, the Lua plugins and the graphite output are his work, for example. And yeah, that was it. Thank you very much.
Thank you very much.